My dear students, welcome to this second module class. Today we will see how exactly stacks are being used for specific applications which are there in the syllabus. In the last class I explained to you there are some applications that you can use it for the purpose of bracket identification, bracket checking and palindrome checking. There are plenty of applications are there for stack. However, in the syllabus you have two specific applications. Of course, these are also being used in your compilation process. Basically, the two examples we see now are related. They are not separate actually. Once you understand one process, then the second process will be very easy. So, which are the two different cases you will be seeing it in the syllabus as applications of stack. One is called infix expression to postfix expression. This is also called as a Polish representation, and second one is called as a expression evaluation. Since you have not heard of these two words, so it looks something different, but as you proceed you will see the representation of these in computer science so often will be used. What are these things? Basically, till your engineering class, till today's class, you will be seeing any mathematical expression represented in the form as a infix expression. Since this word is not being attached, the word looks something different. Otherwise, all the expressions that you have seen so far in your earlier days till today, they are all in the form of infix. It means between two operands, operator will be there. Say for example, if I write x is equal to a plus b, like this you would have seen a big equation, something like that. In this case, if we write the operator between two operands, then this kind of expressions are called infix expression. It means operator is there in between operands. So, that is why it is called infix representation. Operator is fixed in between operands. So, that is why it is called infix representation, and this is what we have seen in our life so far. Whereas, in computers we do not use this infix expression as a way of representing equations and way of getting the solution for any kind of expressions. You know that in any engineering aspect, most of the solvation of problems will be through equations, and these equations are represented conventionally on the paper, and all our teachers till today they taught us how to write always expression in the form of infix. It means operator is there in between operands. There is one serious difficulty that we face when we represent as it is inside the computer. What is that? This can be seen like this. Say for example, I will write an equation x is equal to a plus b star c divided by a plus b, something like this. If I write an expression x is equal to a plus b star c divided by a plus b, as and when you see this equation, all of you are very familiar that b and c to be multiplied first, b and c are to be multiplied and n to be added. So, whatever resultant you get, you need to divide that by b plus c. b plus c divided by b star c divided by a plus b, you are doing it. To that you are adding a, right. It means which inner operation you are doing first. If you know value of a, b, c and all, to compute this x value as per this equation, which part of the equation you are executing first. In fact, if you ask me, you are supposed to do a plus b first, keep it aside, then make b star c ready with you, then divide that b star c and a plus b that you have kept already and divide that, and later you can just do the addition. But how do you know that when the equation is so big? If it is so big, say for example, I have here x is equal to a plus b star c divided by d in plus a minus b divided by a star d slash a, something like this. If it is there, you know that this is an infix expression, infix equation represented wherein which operator is there in between operands. It's okay. Now the question is, which part of the equation to be computed first to get my whole result? I cannot just do like this, a plus this. In this case, which one to be carried out first? We know that since we got i's, we look at this. I know that I am trying to do this operations first, a minus b. After that, I am doing computation of this a plus b. Even though expression is there from the left side, but I try to compute this part of the equation, this part of the expression to be computed first, next this, to that multiply by b, then I am adding this a. So therefore, depending on the equation type, which part of the equation, which part of the expression you are computing first, so that will be decided. Your teacher would have told use brackets, so wherever it is possible, so therefore you can do that first. So since you got compiler in your brain and you will be thinking and looking the entire equation at a time, you will be deciding which part of the equation to be executed first. So you know that when expression is given to you in the form of infix, it is very difficult to identify which part of the equation to be executed first, especially in the computers. Whereas when you got two i's and look at the entire equation, you can just decide. Whereas when your equation has been given in this way from left to right in the form of strings, it is very difficult to identify which part of the expression to be computed first. That you will be not really getting it. Just to facilitate this, so people try to convert expression itself into another form which is readily usable for getting the solution. So this step is followed in every computer. First of all, expression through your program, through your keyboard, you are writing this in the form of infix only. As and when it is going into the compiler, there is a program written in the compiler converts this infix expression into postfix expression. Postfix expression, this is also called as a Polish, I told you in the beginning. We convert this expression into Polish expression first, and from the Polish expression it will be very easy to compute. So that we will be seeing it with an example when we proceed. First of all, let us see what is this postfix expression. Postfix expression is, as the name itself says, so we try to represent operator as a post of operands. So that is why it is called postfix. Operator is fixed to the post of operands. In this case, if you look at this, this is AB plus. I am trying to write this operator after two operands are available to you. So this is called postfix expression. Any infix expression can be converted to postfix expression, and once you look at this postfix expression, after seeing this example, you will be observing by yourself that it will be very, very easy to know which part of the expression to be computed first. So it will be easily be decided by that. So that is why we convert infix expression to postfix expression. So how do you ensure that actually it has been converted to postfix? In case of infix expression, brackets will be there. You know that our mathematics teacher in our high school days and all would have told, use brackets only to ensure that which to be computed separately, to be computed first. Whereas in case of postfix expression, absolutely no brackets will be there. Brackets are only to indicate which part of the program expression to be computed first. So, therefore, there will be no brackets and all the operators will be coming after the operands. So, these two things you have to keep in your mind. So, then the process will be very, very simple. Okay. So, first thing we have to observe out of this process of converting this expression into postfix expression is this. So, there is one more called as a prefix expression. Of course, as you know how to convert this into postfix, in a similar way you can just do prefix also. So, prefix means actually plus, first you are doing the operator, then followed by two operands to be operated on this operator. So, I am doing addition operation on A and B, something like this. I am now doing on A, B, I am doing addition operation, something like this. So, we are familiar with this. Now, we are trying to learn how to write operator as an post of operands. So, this is called postfix expression, right. So, how do you do this postfix expression conversion from infix to postfix, right? Okay. The procedure is using a stack. I am trying to use a stack to convert infix expression to postfix expression. So, what is the, how I am using this stack? So, please remember this in your mind. 1, I am giving input as a infix expression, which is basically in the form of a string. So, when I write x is equal to a plus b star c, something like this, or I will take this a star b plus c, something like this. First I have to do addition, then I have to do multiplication, a star b plus c. You know that this is to be multiplied, added first, then multiplication. All right. Okay. If you write a postfix expression, so you have to know which is the input you are giving. So, you are giving this one as an input. So, therefore, you have to understand I am having one input. Input is a star open bracket b plus c close bracket. 1, 2, 3, 4, 5, 6, 7 character input you are giving. So, this is the input you are giving. I am trying to get something output. The output is something like this, a followed by b, c plus star. So, this is how it will be there. We will see how to convert this later, but you will be getting like this result, operator, operands followed by operator. Okay. So, this is how the postfix expression will be there. Do not worry how this has come, I will explain to you, but right now you see that this is how it looks like that. So, therefore, I am having input like this, input infix expression, output in the form of this, always operator after operands like this. All right. Now, I am using in between a stack. Stack as an intermediary storage. This intermediary storage is used to store only operators. So, please remember this in your mind. I am using to store only operators inside the stack. I am not storing operands here. So, therefore, plus, minus, star, division, exponential, all those things will only go into the stack. Okay. So, this is how the whole process looks like. How to do this? So, what I do is I am trying to have one empty output first. 1, 2, 3, 4, 5, 6, 7 characters are there. So, therefore, leaving out these two brackets, ultimately you will be left with 5. So, therefore, 5 is sufficient for you. So, you please try to take on empty output string first of all. I am calling this one as a postfix output. Input is this. All right. Now, I am using this stack. I already told you stack is used to store only operators, not operands. So, there is one specific algorithm. The algorithm goes like this. If you carefully observe this algorithm, what I am going to do, so then the process will be easy. Okay. What I am doing is, I am doing first of all look at the equation. You know that whenever multiplication comes, So that is always there with a higher precedence compared to addition, that I know that. Whereas when the exponential comes, so still that will be there with a higher precedence. So like this, first of all I set myself the precedence for each of the operators, type of operators you get it. So I try to do plus and minus as one type of precedence. Similarly, star and division, multiplication and division as a second kind of precedence, and rest of exponential is a third kind of precedence. I am trying to give in this way. So therefore, you please look at this. So I am trying to write one chart first of all. So here plus and minus, they are there with a precedence called 2. Similarly, star and division, they are there with a 4. You can as well give 1, 2, something like that actually. Since I have used the same kind of precedence in my program, so I am giving it like this. So then exponential, you are using cap usually, so that will be there at the 6. I have already told you, you can give 1, 2, 3 also, no problem, right? Okay. Then similarly, you can also give, there is one hash symbol. You will be using this hash symbol as a beginning marker. Okay, something marker, you are using this in your stack just to indicate that actually when you reach this hash symbol, so then no more operations to be carried out. It means something like this. I am trying to add something hash to begin with. So therefore, when how to stop this operation, whenever you get hash again after doing all the process, it means it is end of the process. So just for that I am using one hash symbol only for the reference actually. I am putting hash and doing some process. At the end, if you get hash again, it means end of the operation. So like that. So I am using this hash symbol, and similarly we have here open bracket and close bracket you get. Open bracket is interesting. Open bracket will have highest precedence when it is there in outside, but when it goes inside, this will be the least precedent. So this you have to keep in your mind. How to understand? Here sometimes you get open bracket, sometimes you get star, sometimes you get plus. I told you only operators will go inside the stack, operands will directly go to the output. Okay, we will see the procedure later. So whenever you get open bracket is having an interesting kind of precedence. When it is there outside, its precedence is highest amongst all. When it has gone inside, it has got a lowest precedence, right? Why I am doing this? Now the entire operation is based on the precedence only. So that's why I am having different kind of precedence. Whereas plus, minus, star, hash, exponential and all, they are having the same precedence as I mentioned there, 2, 4, 6, something like this. Hash, you call it is 1, lowest, all right. Open bracket will have 2 status of precedence. It is just like tiger. Somebody will be tiger at outside, when they come inside they are at something, they are like rat, like that. When the open bracket is there outside, it is highest precedence. When it is there inside, it is the lowest precedence. So that you have to keep in your mind. So that's why I have not written on the board. So what is the logic? What is algorithm? Take this input, read character by character. You know that there are 7 characters, 1, 2, 3, 4, 5, 6, 7. There are 7 characters. Read character by character. Read character by character. If you get an operand, don't transfer it to stack, transfer directly to output. All right. So transfer directly to output. So therefore, I am transferring this as it is. So please remember, whenever you get operand, directly transfer it to output. Whenever you get operator may be plus, minus, star, division, exponential, brackets, only 5 types. Whenever you get an operator, now you have to look at the precedence of the stack top. What is there in the stack top? I already told you something, you push something in the beginning called hash. Hash is there inside the stack right now, just to indicate this is the beginning. Like in our earlier class I said, actually stack top is equal to -1, something like that I started. So there is something like that. So now I add up something star to indicate that is where all our operation starts. So therefore somewhere you would have already inserted hash into this, which is having lowest precedence. So simple rule is, as if you get an operator, now I am getting an operator. Now operator is star. Look at the precedence of the current operator and look at the precedence of the stack top. If this is lower and this is higher, simply transfer it. You have to ensure that on the lower, higher can sit. On the higher, lower cannot sit. So this is the logic, simple logic, right? So since the stack top is hash, its precedence is 1, star, its precedence is 4, I can transfer star over here. I can transfer over here. The rule is very simple. Take the operator. If the precedence of the stack top is lower than, like this actually, you please remember like this. This is the operator under current consideration. This is the stack top. If the precedence of this is lower than the precedence of this, in this case this is 1, this is 1, this is 4. So therefore 4 can sit here. On lower, upper, higher precedence can sit. So therefore it can sit. Sometimes you may get the stack top precedence is higher than the precedence of the symbol under consideration. You will be seeing with some examples later. If that is the case, so then take out the element from the stack, till you get the stack top precedence is lower than this. When you take out element from the stack, where do you put it? You put it to the output, that is it. Transfer it to the output till the stack top precedence is low, not even equal actually, it must be lower. It must be lower. So keep removing the elements. So therefore, now we have seen some examples. We will see what will be the status of the open bracket. I have already told you open bracket always will be there at the highest precedence once it is there outside. So therefore, now the next symbol under consideration is actually open bracket. This open bracket is of what precedence? Higher precedence compared to the stack top. Stack top is star, its precedence is 4. Open bracket, its precedence is higher when it is there outside. So therefore this is higher, this is lower. So therefore I can transfer it. This is not C, this is open bracket. Okay. So I will take this as D. So therefore it will be easy for us to understand. Otherwise this get confused with the open bracket. C get confused with the open bracket. Okay, I will just take this A star open bracket B plus D close bracket like this. So now this is open bracket. Now what is the precedence of the stack top? Stack top precedence is the lowest precedence now. The reason is after going inside, its precedence will become the lowest amongst rest of them. So therefore now it is 1. You can consider the precedence of this is 1 like this. Okay. Now we have seen some cases. Okay. Whenever you get a close bracket, what you do? Whenever you get a close bracket, take out elements from the stack, transfer it to output till you get open bracket. Keep removing from the stack and transfer it to output till you get open bracket. Take out open bracket also but don't transfer it to output. So this is the logic. Okay. Next, I think we have seen all possible cases. Okay, we will see how this will go on. From input to output, I will write now in a very simple way what are the activities you are supposed to carry on. I will write it on the board, so therefore you can understand. Okay. Step 1, read character by character from input. Read character by character from input like this. 1, 2, 3, 4, 5, 6, 7 elements are there. So read one by one. Second, if you get operand, transfer to output directly. No, nothing to worry. If you get operand, transfer directly to output. Okay. If you get operator, then what you are supposed to do, compare precedence of the symbol, and instead of that I can call it an operator. Compare the precedence of the operator with precedence of stack top. First of all, you compare the precedence of the operator under consideration with the stack top. What is there in the stack top? Okay. Now, what to do if stack top precedence is lower? I'll just erase this. If the stack top precedence is lower, then transfer operator to stack. Simple. If the precedence of the stack top is lower than the precedence of the operator, then simply transfer it. Otherwise, what do you mean by otherwise? It means the stack top precedence is higher, current operator symbol precedence is lower, then what I should do? If that is the case, please remove elements from the stack till you get the stack top precedence is lower than the current operator precedence. So otherwise, remove elements from the stack, okay, transfer to output, till you get a status of stack top precedence is lower than current operator precedence. You have to observe this carefully. If you get operator, compare the precedence of the operator with the precedence of the stack top. If the stack top precedence is lower, then transfer operator to stack. This is straightforward. Else, otherwise, remove elements from the stack, keep removing elements one by one. Each time when you remove, post it to output. So, remove elements from the stack and transfer to output till you get the status of the stack top. Stack top precedence is lower than the current operator precedence. So, till then remove and post it to output. Keep doing this to the output. Alright. So, this is the step you are supposed to follow for operator. So, two more cases. 4. If you get open bracket, what I should do? Nothing to worry. Simply transfer it to stack. Why? As I already told you, its precedence of the open bracket is always higher compared to any other elements when it is there outside. After reaching inside, it is the lowest. So, that you have to keep in your mind. So, therefore, since I am comparing this with the stack top, so this will be always higher when it is there outside the stack. So, once it has gone inside the stack, its precedence will become lowest. So, therefore, no need of checking. Same rule applies here also, but if you get open bracket, simply transfer to output, not output, to the stack. Simply transfer to stack. So, this is for open bracket. Similarly, for close bracket, step number 5. What I should do if I am getting close bracket, I will be writing it on the top. This is step number 5. If you get closed bracket, remove elements from stack and transfer to output. Till you get open bracket. So, keep removing elements from the stack, post it to output till you get open bracket. Once you get open bracket, remove that open bracket also, but don't send to output. So, this is the difference. Remove that also from the stack, but don't post it to output. If you get closed bracket, remove element from the stack and transfer to output till you get open bracket. Open bracket ಸಿಗೋವರೆಗೆ remove ಮಾಡ್ತಾ ಬನ್ನಿ. Open bracket no remove ಮಾಡಿ, ಆದರೆ output ಮಾತ್ರ post ಮಾಡಬೇಡಿ. Remove that open bracket also, but don't post it to output. So, 5 cases we have seen. So, 1, 2, 3, 4, 5 like this. So, if you follow this, then everything is done. So, till you will be doing all these steps 1, 2, 3, 4, 5 steps till what time? Till input is exhausted. Till you get this, till input symbol get exhausted. Once input symbol get exhausted, then remove element from the stack if there are anything left out, transfer it to output. So, that also you are supposed to do. Finally, I will be going up to this part, last character, and do accordingly according to any of these steps, and finally once you reach that no more input symbols are there, either operand or operators, that is the end of operation. Take out elements from the stack if there are any left out, then transfer it to output till you get a hash symbol. Hash symbol is only the beginning. So, I have just put one hash symbol, so just to indicate this is the beginning, right. So, once you till you reach this hash symbol, so you will be transferring everything into output, and what is there in the output, so that is nothing but your final postfix expression. So, this is how I am this is how we are trying to convert infix expression to postfix expression. So, what I will do is actually I will now demonstrate the same thing with a computer. So, therefore, you can understand this better. I will stop this an explanation right now, and I will switch over to computers immediately after this. So, thank you very much.